Hello students, I am Dr. Vipin B. Gawande and welcome to video lecture series in engineering graphics, and today we will discuss the engineering curves. Now the first topic is the conic sections. The conic section means when the cone is cut by means of the section plane, so we get the curves like ellipse, parabola and hyperbola. So these are called as the conic sections. So the ellipse is obtained when the section plane or the cutting plane it cuts the generator and the axis. Generator is a line which joins the apex of the cone and the point on the periphery of the circle. So section plane cuts the cone and the resulting curve is a ellipse. Okay. To get the parabola, the section plane cuts the axis and it is parallel to the generator. So the resulting curve is a parabola. To obtain the rectangular hyperbola, the cutting plane cuts on one side of the axis, it is parallel to the axis. So the resulting curve is a parabola. Okay. Now the most important thing in this curve is a term eccentricity. Eccentricity is defined as the ratio of the V up upon Vc. V up means it is a distance of the focus from the vertex, and Vc means it is the distance of the vertex from the directrix. C up is the distance of focus from the directrix. So these terms are very important. C up is the distance of focus from the directrix. V up is the distance of focus from the vertex, and Vc is distance of vertex from the directrix. Now for ellipse, the eccentricity is less than 1. So example, V up by Vc is 2 by 3. Now if this problem is given, so then we have to divide this C up into the addition of this eccentricity. So 2 plus 3, so 5. So 1, 2, 3, 4 and 5. Now in this case, V up is having 2 divisions. So 1, 2. So here we have to mark V. Vc is having 3 divisions, 1, 2 and 3. For parabola, eccentricity is 1, that is V up is equal to Vc. So the vertex comes at the center of this C up distance. So take the center of C up distance and mark the vertex. For hyperbola, eccentricity is greater than 1, that is the divisions are 5, 3 plus 2, and V up is having 3 divisions. So 1, 2 and 3. So vertex comes here, and Vc is having 2 divisions, 1 and 2. Okay. So this is the marking of vertex when the distance are given. Now let us take the first problem. The vertex of hyperbola is 65 mm from its focus. So distance of the vertex and distance of focus and from the vertex it is given. Distance of vertex of the hyperbola is 65 from its focus. So VF distance is given in the problem. So VF is equal to 65 mm. Draw the curve if its eccentricity is 5 by 2. Now 5 by 2 means its eccentricity is greater than 1. So we have to construct the hyperbola. Now in this case, VF is given, we have to find out to Vc. So use the formula for eccentricity. VF by Vc is equal to 5 by 2. Put the value of VF here, calculate Vc. Now once VF and Vc is known, so take Vc distance 26 mm and VF distance 65 mm. So this is okay. Consider this as a C. Vc is equal to 26 and VF is equal to 65. Once you get the vertex, so then take VF distance in compass, mark the R, okay, on the vertical line passing through V. You will get point B here or A. Draw a line passing through that point. Okay. After that, mark the distance. Take small distance in compass and mark the divisions after the V. Okay. Draw vertical lines from that divisions. Take 1 dash distance in compass from F. Cut the same line. Take 2 dash distance in compass from F. Cut the same line. Take 3 dash distance in compass from F. Cut the same line. 4 dash distance in compass from F. Cut the same line. 5 dash distance in compass from F. Cut the line, and then join the point. So you will get the required parabola. So this is the procedure for drawing the hyperbola for this problem. Remember, in this problem we are not given directly total distance, CF distance, but distance of focus from the vertex is given, and then we have find out the VC remaining VC distance. Okay, so this problem is very important. The second problem is for the parabola. A motor car headlamp is having an aperture opening of 0.16 meter. Okay, so we have here, this is aperture opening, this is our base, okay, and depth 0.115 meter, that is our height. So for parabola, two things are required. One is the base AB and another is the height OC. So in this case, this aperture opening 0.16 meter, it denotes the base AB, and depth 0.115 meter, it denotes the height. Now since the dimensions are in units are in meter, so we'll assume some scale. Let 0.01 meter is equal to 6 mm. Then this base 0.16 meter, it comes out to be 96 mm. So this is 9.6 centimeter or 96 mm. And the height, that is 0.115 meter, using this scale, it comes out to be 69 mm or 6.9 centimeter. For parabola, once you get the base and the height, you have to use the rectangle method. Then complete the rectangle and divide this line into, suppose it is divided into 6 divisions using line division method. Similarly, you have to divide this line also into 6 divisions. You can take any number of divisions, 5 here or 6 here. Here I have divided it into 6 divisions, 1 2 3 4 5 6. Use here line division method. Similarly, use here line division method and divide these lines into 6 divisions. Remember, we required equal number of divisions on this line and this line. Okay, now the next step is join C1, C2, C3, C4, C5 lines. Okay, similarly on the other side, and then join from 1 to 1 dash, 2 to 2 dash, 3 to 3 dash, 4 to 4 dash, 5 to 5 dash. Similarly here. Okay, then you will get the points here: P1, P2, P3, P4, P5, P6, P7, P8, P9, P10 and P11. Draw a curve passing through these points using the French curve. You will get the parabola. Okay, so this is the method. Okay, here you mark 1 dash, 2 dash, 3 dash, 4 dash, 5 dash. Okay, 1 2 3 4. We require equal number of divisions here and here. Okay, so this is AB is our aperture opening and OC is our depth. Okay, I have assumed here the scale 0.01 meter is equal to 6 mm. So 0.16 meter becomes 96 mm. So that is our base, and 0.115 meters becomes 69 mm. So that is our height. Okay. Now let us see how to divide the circle into 8 parts. Okay. Now to divide the circle into 8 parts, draw a circle of given diameter. Draw one horizontal diameter, vertical diameter, and then take 45-degree angle. Okay, here take 45-degree angle here, and then join the lines. So the circle get divided into 8 parts: 1 2 3 4 5 6 7 and 8. Okay, now how to divide the circle into the 12 parts? Draw a circle of given diameter by taking the radius. Now draw horizontal diameter and vertical diameter. Now take radius distance in compass. From the horizontal diametrical ends, mark radius distance here on the other sides. Similarly, from this corner, mark the radius distance from the other sides. Now use vertical diameter. From diametrical ends of vertical diameters, mark the radius distance on both sides. Now from here, mark the radius distance from these two sides. Now join all the points. The circle get divided into 12 parts. You can use both the division methods, that is circle get divided into 8 parts or 12 parts. Okay. Now this problem is simple. A wheel of motorcycle 60 mm in diameter, 30 mm radius, rolls on a straight horizontal road. Okay. Draw the locus of point on the periphery of the wheel. Assume point P away from the road. So P is given here. So you have to mark we already saw this problem in the classroom. So take here 1 2 3 4 5. Okay. So take the classroom solution. I have given just the solution from the book. So solve this problem using the regular method what we have used in the classroom. Okay, the curve will come something like this. So if P is here, So then this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can divide this circle into 8 parts also, but the profile of the curve must come something like this. Okay, so follow the class notes and solve this problem. Okay, now the next thing is the next problem. It is on Archimedean spiral. Rod AB 60 mm long. So this is rod AB. Okay, it is rotating uniformly about A. So this is A point here. During the time rod completes one revolution, the P starts from B. So P point starts from here and then it is going to A, uniformly towards A, and reaches back to B. That means P point is going to A and then again coming back during one complete revolution. And name the curve. Okay, draw the path traced by the point P and name the curve. So the curve is the Archimedean spiral. Now what is this? The concept here, during the complete revolution of that rod AB, point P travels from this end towards A and then again comes back. Now the concept is simple. We have divided circle into 12 parts. So in 6 division, the point P will reach from this end to this center, and then in remaining 6 division, point P comes toward its initial position. Okay, so it is very simple. So divide circle into 12 parts: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Now now the point P must reach in 6 division, it must go to the center. Okay, so we have divided this into 1, 2, 3, 4, 5, 6. So we have divided this AB line into 6 divisions. Okay, and then while coming back, it is 7, 8, 9, 10, 11 and 12. Okay, so that means there are 12 divisions of 12 divisions. That means we have make here the 12 divisions. So that is forward 6 and backward 6. Okay, so in 12 divisions of the circle, the point P, it travels 6 divisions. It will reach here, and while coming back in 6th division, it comes to its original position. Now how to mark the points? Now 1 from center take radius 1, it goes to 1. From center 2, it goes to 2. From center 3, it goes to 3. From center 4 radius, it goes to 4. Then center 5, it goes to 5, and last point is the 6. Okay, now it comes to its center. Now it will go back to its original position. So we will take now 7. So center and 7 radius, it is 7 here. So cut the line 7. Center 8, it cuts the line 8. Center and 9 radius, it cuts the line 9. Center and 10, it cuts the line 10. Center and 11, it cuts the line 11, and then it comes back. Now we got 6 points when it travels up to center, and 6 points when it comes back to its original position. Okay, so this problem is very important as per as the examination. You also solve this problem in the unit test also. Okay, thank you very much.